Visualize a scenario. Here we have a video scenario of what we're going to do on demonstration day. Hopefully it's shiny, so let's play the video.
I see 3 hostiles and 1 hostage, over.
Vital sign monitoring activated.
Alright, we have the VIB system up and running. Officer Shimoda, give me a status on the team.
Officer Novella, good condition. Officer Pintor, good condition. Officer Marquez, good condition. Officer Sandoval, good condition.
Alright.
We interrupt this broadcast for the coverage on the current hostage situation. We have a recording of the current demands.
And we want $1 billion.
Danger. Vital signs critical.
Officer John Novella, in critical condition.
Need to send the rest of the team. Notify them.
Squad, copy. Officer John Novella, critical condition.
John, are you alright? Speak to me!
Depending on the weather, I invite everyone to design day, either outside or inside. It's all good. We're going to have some barbecue if it's outside, or some food inside. It's at 12 o'clock this Friday, December 11th, and that's our presentation, and thank you everyone for listening. We open up the floor to any questions that you may have about our project. Sir in the rear.
First of all, I think that's awesome. Like, if you haven't already, like, advertised it to firefighters or whatever. But what was inspiration for how the vest was designed? Because it looks pretty cool. I like to just wear it to play sports too. Do you know where the?
I think at first we pretty much wanted the vest to be as tight as possible, so that all of the sensors can be snug on the skin, so that they can do their job. We wanted it also to be elastic, also be able to wick sweat, because this is going to be on the skin. So a firefighter is putting this on, he's sweating, he's working. We wanted it to be as comfortable as possible, but also to be durable enough to do its job as well.
And an aside, all the things you're monitoring are also involved in lie detector tests.
Tell us a little more about how you measure the blood oxygen content. This is actually by reflection. You went through.
Right. Well, it's a commercial off-the-shelf product. It's non-in medical.
Where does it measure? What part of the body does it measure?
So we're going to place this on the chest. Actually, you can have 3 different types of pulse oximeters. You can have the sensor on your finger, you can have it on your forehead, you can have it on your chest. So pretty much for our design, we wanted this thing to be able to take the vest on and off without adjusting any sensors. So we figured we're going to take away the finger one, we're going to take away the forehead, and we're going to mount it on the chest so that it can be straightly, so it can be on the chest at all times. So that's why we went with that.
And the way it detects blood oxygen level is it sends light, and the reflection changes depending on how much oxygen is in the blood. That's how it detects oxygen.
Right. Some of that light is absorbed by the blood. Some of it is reflected, and the photodetector takes that, turns it into a voltage, sends it into that module for processing, and then it calculates that percentage of blood oxygen saturation. It does the same for heart rate.
The reason to believe that is an accurate
Well, if we take a look at the specification sheet, it's telling us, you know, plus or minus 2 digits at rest, plus or minus 3 digits during exercise. So that's pretty much what this product is telling us, and that's what we have to do. So beats per minute. So let's say you're at 90 beats per minute, it'll be plus or minus during exercise.
Measuring
Heart rate
Yeah.
and blood oxygen saturation.
It sends out two sets of data. It sends it out serially. It sends out a bunch of packets, but in that there's a percentage, which is usually around 99%, 98%. That's the oxygen level. It also sends the beats per minute for the heart rate.
Can you describe how you use accelerometer information to determine the body position?
Yeah, so the output voltage of the accelerometer is at 1.6, that would give us a full G. So when it's so standing up, you know, you're on the positive X direction.